Hello, welcome. Let's try to solve a design problem. 1476 subrectangle queries. So we're gonna solve a subrectangle queries problem. Let me make a drawing to explain what is the problem. Yeah. So for example, if we have a rectangle like that, and we're gonna check something. So this is the rectangle from the beginning. We're gonna update the rectangle and get a value of the rectangle. So how can we get a value? Yeah, that is just index R and C. We can get the value. For example, this is 5. Yeah, and we also have an update rectangle function. And so this update just means at some area, maybe at this area, so we're gonna update all the values to 5 or 1 or some values, but it's gonna be the same value. Yeah, so it's gonna call the get value or update rectangle update yeah, it's gonna call the get value function or the update subrectangle function, yeah, respectively. It can be any kind of sequence. Yeah, this is so difficult to spell. Update subrectangle. Yeah. Now let's just check the constraints to check if we can solve it by brute force. So the row and column is 100, and there is at most 500 calls. So it means 100 times 100 times 500, it is 5 times 10 to the power of 6. So this means we can solve it by brute force. Now let's just solve it. So self.rect, this is just a rectangle. Yeah, we're gonna prepare the rectangle and then we're gonna try to write the update function. I'm gonna use R and C, length of the self.rect and length of the we just need to know the row and column. Yeah, so here for simplicity I always use R and C. So for R in range, so we're gonna starting from row 1 to row 2 plus 1, and for C in range of the column, I'm gonna starting from column 1 and column 2 plus 1. Now we just need to update the values, so self.rect with R and C should equal to the new value. Yeah, so this is the update function, and finally we just need to get to the final result. So the final result is just self.rect and row and column. Yeah. Now let me submit it to check if it works. As you can see, it works. And the time complexity, as I explained earlier, it is 100 times 100 times 500 calls. Thank you for watching. See you next time.